In this video, what we're going to do is we're going to calculate the area of a circle. Then we're going to go back and calculate the circumference of the circle. So there's two different formulas, both of them using the radius and the diameter. So we're going to start off right off the bat with include iostream, and we need to do include iominute. So now we have our includes. What we're going to do here is, remember, this is very important. In the very beginning of your program, you're going to want to write your name and the name of the program or activity or assignment, and I'll just call it circle. And then we'll do this program will calculate the area and circumference of a circle. Hopefully I spelled it right. So we have this. Now we have our includes. And you're going to do using namespace standard. We're going to be doing this in the beginning. Then we're going to change to a different way of doing it, which is more C++ standard. So we start our main. We do our brackets. And remember that I recommend putting comments for every closing bracket. And don't forget we need our return statement. So the first thing we need to do is figure out what are the formulas for a area and what are the formulas for a circumference in there. So we can put it up here if we want, and we'll just do area equals pi r, and I'll just put squared, which I think I probably spelled wrong. And circumference equals pi. Notice the pi is in capital letters. Pi times the diameter. And then you can go back and make any cosmetic changes that you need here. So the first thing we need to do, and this is important. Now, you know I made a big issue about not declaring global variables, and we'll talk more about that. When you have a, let's see, why is this here? Who cares? Program didn't like my spelling in here, but they'll get over there. So let's go up top here after namespace. And I did mention that you should never declare a global variable, because that means something can change the value of it, could cause your program to give the wrong results. However, if you have a global constant, that's recommended. When we get into functions, you'll see that this way solves you the problem of having to pass them. Don't worry about that for right now. Let's just take the word constant, C-O-N-S-T, then the data type in capital letters, and the value is 3.14159, I believe. It's close enough. So let me show you something that if I were to try to now do pi equals 4, notice I'm getting a red squiggly line that says, hey, you can't do this. Expression must be a modified value, so you can't do it. So it doesn't matter. That's why we declared a constant, so we know that we can't do it. So the first thing we need to do, and we'll use integers for this. Let's do an integer, and we want a radius. And we want a diameter. And we want an area. Now I'm going to put area circle. And can anybody see anything wrong with this, I'll give 5 seconds out, going once, going twice, going 3 times. And that's good. It's okay if you didn't. The answer is the area, we have it as an integer, and in all cases, it's going to be a float or a double. So what we need to do here is we need to make this a double. And then we want to do 0.0. And then we'll also do diameter. So now we're looking good. So the first thing we need to do is we need to get the radius of the circle. There's really no need to get the diameter of the circle because the diameter is 2 times the radius. So we could also multiply 2 times the radius to do the diameter of the, let's see, diameter. Actually, this, I knew there's something looked wrong here. So we need to do circumference. That's what I want. So that looks good there. And first thing we need to decide is, are we going to do the radius first? We're going to do the diameter. Well, it really makes more sense to do the radius first, but either way is okay. So first thing we can do is see out what is the radius. A little question mark, make sure you put a space, make sure that you put no end line. And then we're going to do Cn radius. So now right off the bat, we know that the diameter should be 2 times the radius. So let's just go and do diameter equals 2 times the radius. So here is a good way now to test to see if everything's looking good. So I'm going to do C out radius and then diameter and then end line. So the reason why I'm doing this is to make sure that we're calculating the diameter correctly. So, and make sure that the radius, there isn't some kind of issue with the input of the radius. So let's go and run this program. Now, I got some questions on how to run a program. One of the ways that you can do it is go to debug and you'll see Control F5. That's the way I do it, but that's going to only work on Windows. So you don't really need the debugger right now. We'll do it without debugging, or you can just click up top here on the green arrow. And I think you can also click on this one here. So now we have what is the radius? So let's just make it 5. And the radius is 5 and the diameter is 10. So we have a little bit of cosmetic issues. So let's just put a space there. So we know that works. So let's try something different. Let's just say hypothetically, and we're going to talk later on how to make sure this doesn't happen. Suppose a person puts 5.75 for the radius. Let's see what happens. Okay, radius is 5 and diameter is 10. Because the radius is an integer, it's going to just chop off this 0.75. So that's not a big deal. So now the next thing we need to do is calculate the area of the circle or the circumference of the circle. It really doesn't matter which one we do first. So let's just do circumference circle equals pi times the diameter. And then the area equals, now we're going to do it two different ways. One the easy way, one the actual preferred way. So we're going to do area equals, and it should be area circle. And we'll do pi. Now remember, it's pi r squared. So we do radius times radius. Now, the problem with this is that works okay if it's r squared. But what happens if you need to do something cubed or something to the fourth power? But notice I'm only putting parentheses here because if everything is of the same sign, then it's no big deal. So we're multiplying and multiplying, so it's really no big deal. So a better way of doing this would be to do the area, and we'll comment this out in a second, equals pi times POW stands for power. And what we're going to do is radius times 2. Now we're going to get an error because right now we actually should get an error, but we're not getting it for some reason. That might be the new upgrade. What you really want to do, just to make sure, because it works on this one, doesn't mean it won't work. It will work on others. So in order to do that, you should include CMath in there. So if you're working on Xcode or you're working on Eclipse or something else, it's quite possible that it's not going to work. So you want to make sure you do it. So let's run this here and see. So we don't really need this right now. And we don't need both of them. So let's go see out the circumference is, and I'm going to do circumference. And there's a little trick too that I'm going to show you that is perfectly acceptable to use. It's your call. Now I could put in end line and I can put in a whole new C out, whatever you want to do. So let's do it this way first. Then I'll show you another option that you can choose, and you do it whatever way that you feel more comfortable with. Then we'll do C out. The area is area circle and end line. So let's run this, and we'll do it with something simple. We're going to do it with let's do it with 1, and that is a good test because 1 is very easy to multiply everything together. So let's click on this stuff here, and eventually, what is the radius? Let's do 1. So the circumference is 6 and the area is 3. Okay, so obviously we have an issue. So notice what I keep saying is you want to make sure that you are declaring everything, and you want to make sure that you test everything again. So we have pi times radius times 2, so this should be 3.14159 times 1. So we have an issue. So I'm going to put the video on pause, and let's take a look and see if anybody can come up with what the problem is. So let's run this program one more time and try to figure out what the actual answer is. So let's click it up here and see why we're getting that problem. Let's try it one more time. Let's try it with 1 again. So it says circumference is 6 and the area is 3. It really doesn't matter. Say, oh, well, we didn't do set fixed and set precision. So let's go and do that in case you're thinking that's what the issue is. So we'll do C out fixed, and then we'll do set precision to 2. Let's try it again. And then we'll fix a very simple and common mistake. Try one more time. Well, so much for that theory, but it was a nice try. So here's the biggest issue, as you all already saw. This is an integer, which means pi now, instead of 3.1415159, it's 3. So we now need to change this to a double. Now let's try it. And I'm going to comment out this here so you can see what you get if you don't choose fixed in 2. So let's go and do this here. And we'll try it again with 1. So now we have 6.28314 and the other's 314159. So the set precision allows you to display it to whatever decimal points you want. So let's just go and do, let's change it to 3. So let's run it again with something different. And let's try it with 3. So the circumference is 18 in here. So this would be 6 times 3.149. And I'm not going to even try to do this in my head. But 9 is 3 squared is 9. So that would be roughly in there. So that looks good. So now if we wanted to make this a little bit more cosmetic, so what we can do here is we can make the circumference is, and let's see, this would be 3, 4, 5, 6, 7, 8, 9, 10. So let's just make it 20. And then we're going to do it, and we're going to run into a small little problem, but that's easily fixed in here. And we'll set the width of this to, say, 10. So let's go and run this again. So what we're going to do here is we're going to do set width. And let's make it 20. And then we'll do here. Set width 10. Remember, set width only works for one thing. So let's copy this here. And here, and we'll change it to 10. And let's run it again. And, oops, that was not too bright. So let's run it again and see what it looks like. So we'll do 2. Wow. So this is right. So this doesn't really look all that great. So, and we apparently have the same thing because 2 times 2 is 4 and 2 squared is 4. That's why they're the same. So let's see if we can make a little bit of adjustments. So for what we're going to do here, we're going to do, let's make this left. And let's make this right. And we'll make this left. And we'll make this right. So let's see how this works. Now you may have to adjust this to something different. Might make it 22. So let's see what happens here. And we'll use 3 this time. So we have a little bit of an issue here. So, but that's no big deal. So we can fix this. So let's try and change this to 22 and 22. So that's one of the things that I don't really like about C++ and its formatting, because sometimes it's a little bit challenging to try to get things to line up in here. So that's it for here. I'm not going to worry about that. But what you could do is try to add something here and add it to, and let's see if that solves your problem. Normally you do it on a grid, so you know exactly how much we need to do. And there we go. So we saw that that needed to be increased in here, and that lines up. So that's nice. So this is one of the things that the length could be very easily done. So if you use the length in here, you could standard, you don't have to standard count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you can see that we didn't have enough spaces in there. So that takes care of that. And I'll have this posted in a little while. And hopefully this helps.